Yeah, dear students, we are back to our class. In the previous interaction, we talked about the valley curves, and towards the end, we discussed about the grade compensation which needs to be provided where a gradient is being overlapped with a horizontal curve. We could not talk about the hairpin bends in the previous interaction, so we are going to cover it now, and then we will continue with the alignment coordination, which is another important aspect needs to be discussed, because in many of the cases, depending on the terrain, you may have the vertical alignment as well as the horizontal alignment coming at the same location or they are overlapping, and in those cases what needs to be done is what we are going to look at. Starting with the hairpin bends. In the case of hairpin bends, I am giving you the salient features here. The salient features are that if you are talking about a hairpin bend which can be something like this, and the word which has arisen because this is a type of a pin which is being used by ladies in their hair. So, the name comes as a hairpin band. Now, for these the speed is going to be 20 kilometers per hour, and then when you are developing it as a highway. So, the total cross section is going to be there. So, what is the roadway width which will be there, that is what we are talking, and this roadway width we are trying to see that we are going to provide at the apex. So, this is the apex of a curve. At this point, if it is a national highway or a state highway for a 2-lane road, that should be 11.5 meters, but if it is a single lane road, then it can be 9 meters. Whereas, in the case of district roads of the two categories, this is 7.5 meters, and for the village roads it is 6.5 meters. So, that is how we are going to consider that whatever the width needs to be provided at this location has to be maintained. Then the another case is that when you are providing it, then there is going to be the radius, and this radius at the inner curve at the minimum level is 14 meters. Similarly, when you have this type of a curve when you are coming from a straight section, so this is a straight section, then we have a transition curve, and then we have a curve like this. So, there is a transition curve here, is straight here, and a circular curve may be at the apex. Then in that case the minimum length of the transition curve is being also defined as 15 meters. So, they are all minimum things. If it is more than that, it is always going to be better. The another thing is the gradients which are there. The gradient at a maximum can be 1 in 40, but at a minimum level they are going to be defined by the drainage considerations, and that is where we talk about a absolute minimum condition as 0.5% or 1 in 200. So, that is the two value which we can have. So, 2.5% is also quite a reasonable value, but if possible, then we can also make it flatter at that one, only with the gradient that the cross slope is there, and so that the water just drains away whatever comes at the top surface of the carriageway. The super elevation in this case is being kept as a maximum value of 10%. The inner and outer edge of the roadway, they should be concentric with the center line profile of the pavement, and if there are successive hairpin bends, then in that case, if they cannot be omitted, there should be a distance of at least 60 meters between the two bends, so that the driver who are negotiating the curves one by one like this, they have sufficient time to recoup with the first maneuver and then move into the next maneuver. So, that is what we are talking. So, this length should be minimum 60 meters. So, these are few of the things which are required, which needs to be taken care of when we are talking about the hairpin bends. Now, just after completing this particular, say, a small topic, now let us move to the coordination of alignment. So, we are talking about the alignment coordination now. So, there are various features, various considerations which needs to be taken care of. Few of the things, if remember, we talked about when we were discussing the other things previously. So, we are going to take the things forward from there, and what it says first of all, a straight alignment or a flat horizontal curve at the expense of steep or long grades is not going to contribute as a balanced design, or excessive curvature in a road with flat grades this is also not a good thing. So, these needs to be avoided. Then another point is that when you have the two things coming together, then vertical curvature should be superimposed over the horizontal curvature, not the other way around. So, you have whatever the horizontal curvature is like this, on this one if we are going to provide. So, if this is a plan and this is an elevation. So, this elevation is going to be provided. So, this is a straight section, this is a straight section, and in between we have a vertical curve. So, this vertical curve is coming on a long horizontal curve in between that. So, that is going to be better. Length of both curves should be more or less equal, but if it is not a case, then in that case the horizontal curve should be longer than the vertical curve, as I have enumerated here. So, if we can make it equal, it is fine, but many of the times the terrain conditions may not allow you to do that. The reasonable appearance is going to result if the vertices of the horizontal and the vertical curves are kept apart by not more than 1/4. So, as far as possible. So, this is the apex of the say the circular curve, and this is the apex of the vertical curve. If they are coinciding with each other, it is fine, but if there is a small distance between these two, which is being defined as 1/4 of one phase. So, one phase is like one changeover which is going to be there. So, if we have up to that much also is satisfactory, but if it is going beyond that, then that is going to create a poor coordination or a poor appearance. So, we have to take that also into consideration. Now, the grade line for a long flat horizontal curve should not be interrupted by short dips and humps. So, you are going continuously straight like this. So, this is a grade line, and there is a horizontal curve which is coming on the top of that, but after that what we see is that there is a dip like this or a hump like this or a dip like this, and then we go. So, if this type of a thing is going to happen, then it is going to create a big problem. It is a problem in terms of perception, it is a problem in terms of understanding the thing and then behaving or responding to it or reacting to it. If the vertices of the two curves are slightly out of phase, the vertical curve should lie within the horizontal curve. So, that is another thing. Sharp horizontal curves should be avoided at or near the apex of the summit or the sag vertical curves. So, we have defined, we have a vertical curve like this being provided, but at this particular point if you are coming with a very sharp curve in this form. So, this is say plan and that is elevation. So, this is going to create a problem in a sense that you have a feeling as a driver that the road is going to end there, and where the road is moving is not known. So, that sort of things should not happen. The horizontal curvature should lead the vertical curvature, that is horizontal curve is made longer than the vertical curve. So, it is just a reassertion of what we have talked previously. The sharp horizontal curvature should not be placed at or near the low point of the sag or the valley curve. So, you are going down and at this point all of a sudden a sharp curve is being provided. This is also not good, because by that time if the vehicle comes, it has already gained the momentum, the driver is trying to control the vehicle speed, and at that point if there is a sharp curve, this can be a sort of a hazardous situation. Then short horizontal curves between tangents appears as optical break, and provision of a long horizontal curve between tangents will improve the aesthetics, and that will also eliminate the optical break which is there. Optical break means whatever you are perceiving, whatever you are looking with your eyes. So, that is optical scenario, and there may be breaks in it because you are talking, you are having certain things in this form. So, you have the tangents, and within tangents you have short curve. So, you are going horizontal. So, this is a tangent and this is a tangent, and there is a short curve here. So, that is going to create a problem. In the case of hills, it is always better to have a larger radii of a summit vertical curve as compared to the valley vertical curve. So, if this is R1 and this is R2, then R1 should be greater than R2. And why this is being done is that it allows longer side distance for the crest or the summit vertical curves. Then in the case of flat topography, or where the difference in elevation along the roadway is not too much, then the radii of the sag or the valley vertical curve should be larger than that of the summit vertical curve. So, there are two things which we are talking in this case. This allows better spatial guideline or guidance which is going to be provided in terms of the total view, which also includes the 3D conditions of the features which are being provided on a road. So, all cumulative condition is being talked here when you are looking at this. The radii of valley or the summit vertical curve should be longer than the radii of the horizontal curve. So, that is another aspect which needs to be taken care of. Short sag or valley vertical curves or the crest or the summit vertical curves, they should not appear in quick succession. That means, we are talking about this type of a scenario. While doing superimposition of elements, the ratio between the radii of horizontal curve and the radii of sag vertical curve should be in the range of 1/5 to 1/10. So, this will allow satisfactory 3-dimensional appearance. So, this is another criteria. There should not be more than 2 changes in the horizontal alignment. So, means you are going change like this and go straight and change like this. So, that is how there is a one curve R1 and another curve R2. But similarly, when you are looking at this, so you should not have V1, V2, V3, V4. What it says that in the case of vertical great line, there should not be more than 3 breaks in the view frame. If they are appearing more, then they are going to again create a problem. So, when you have this type of a situation, maybe we can resolve it by way of if this is not there, then we can resolve it by way of saying this is a superimposition on this and this is, so one is being left at the center, which is going to be taken care of by the tangent. So, it will not create any issue, but if they are more, then this type of a adjustment will not be possible. For satisfactory appearance, the horizontal and the vertical curves should be longer than the minimum design standards required to satisfy safety and operational requirements. Then the another point is the appearance of the kinks can be avoided if the length of the valley curve is almost same as the viewing distance from which the driver first perceived the curve. So, you are driving, you look at the valley curve. So, whatever is the total viewing distance which you have, if you have the length of that valley curve equal to that viewing distance, then this looks perfect. A minimum level is that the length can be 0.6 times the viewing distance. So, the length of curve is equal to V, or minimum length is equals to 0.6 viewing distance, we can write VD. Whereas, in the case of horizontal curve, the length of the horizontal curve should be at least 3 times the design speed. So, this is 3V, or preferably twice the viewing length or viewing distance. So, that is the minimum in the case of horizontal curve. So, these are few things which has to be taken care of when we are having a superimposition of say the various types of features, various types of horizontal alignment or the vertical alignment conditions in a terrain. Now, when we are talking about all of these features, we did talk about the 2-3 types of the guidances. So, there are 3 guidances as such. The first one is an optical guidance, the another is a surface guidance, and the third one is a spatial guidance. So, what is optical guidance? The optical guidance means there is a good view of the road such that the road appears to blend with the surroundings and the direction of the road becomes readily apparent. So, a driver is looking at a road, trying to see what is there on the sides of it within the view frame at a particular design speed or at any speed with which the driver is moving, and therefore, whatever is the perspective view which is coming in the view frame is actually the optical guidance which the driver is getting out of that road alignment. But we are not talking here about the 3D view. What we are talking is a simple guidance in terms of that I have to go left, I have to go right, what way I have to move. The surface guidance is going to be generated out of the features which have been provided in the cross section. So, it is a combination of the cross sectional elements, and these cross sectional elements obviously are like carriageways, shoulders, various types of markings, etc., etc. So, when we have all of these things together, then they are again going to give a sort of a guidance, the sort of a view in which the driver is being able to comprehend that how the driving is to be done, in what direction to be done, at what this level it is to be done in terms of the maintaining of the speeds, etc. And that is how the safety and the efficiency is going to be ensured out of our design. And in this case, when you are talking about all of these elements, then obviously it is going to culminate into a 3-dimensional design. Then the next thing is the spatial guidance, whereas what we are talking is that on these type of a 3-dimensional design elements which are going to be looked at by the driver. Now, we have to balance those things in terms of the design parameters. So, whatever the things we have discussed so far in the alignment design, now each and everything has to be taken care of together. So, the overall composite picture is going to be there in front of you, and that is what is a spatial guidance which is going to be there to a driver. Now, let us look at the various cases where when you have an overlapping, then whether it results in a good alignment or coordination, or it results in a bad alignment coordination, what exactly it is. So, we have few cases on this particular slide here. So, what we found is that these are the cases of poor coordination. Now, what type of poor coordination is coming? Say if we talk about the first one, what you found is that the horizontal alignment is quite straight, but the vertical alignment has lot many curves. So, fluttering of vertical curves is there, and because of that we are getting this type of a view frame. So, this is what is actually happening when you are looking at in terms of an optical guidance which you are getting. Similarly, in this case what you have is the horizontal curve is taking a radius. So, it is turning left when you are coming from this side, and then again you have number of such changeovers in the grid lines are there. So, you are going in the direction, you are having up and downs, and at the same time it is taking a curve. So, what happens is at some point of a time it feels like it is closing out, and then it gives a changeover in terms of a form of a line towards the other one from the side. So, this is again not a good way of viewing that particular road. Here in this case you have again a straight horizontal alignment, but there is a dip. So, this dip has resulted in this type of a nose structure type of a thing. So, you have a profile getting and here, and then there is again a view of a road which is looking very small. So, you do not know what is happening ahead, and you have to be more cautious. If you are not cautious, then you are just going to feel the bump or the thrust in different directions. And the same thing in that particular case, if it is being provided with the curvature in the horizontal alignment, then what is happening is you are going straight and then there is a dip, but as soon as there is a dip, then there is a curvature. So, what you feel is that you are going down. So, there is nothing at the end, but there is a road on one of the side, and this is what is happening here. It is showing a sort of an end here, but there is a road going to this direction. So, this is another type of a view frame which is here, and that is not a good perspective view which we are getting. Now, here also this is a sort of a reverse curve condition, and the reverse curve condition, first of all you are taking a turn towards the right, but then there is a vertical curve. So, you are going down, and then while going down you are taking a turn in the reverse direction, and that is not visible to you. And what you found afterwards is, because the curvature is this vertical profile is coming up, you have been able to see this portion, but in between what is happening is not known. And this type of a situation, because you are going to this direction and then get to this one, is defined as jumping. So, here you can see the cases, like in this case there is a profile where the profile is going like this. So, it is a one sort of a jumping condition, and here also there is a big dip. So, when there is a big dip, so you do not know what is happening ahead of this point, and it feels like that is an horizon, the road ends there. Then there are another cases that this looks good, but the only issue is that it is not smooth, it is not flowable. So, this not flowable is because of that horizontal tangent which is coming at that location, and it is creating a sort of a kink in the view frame. So, that is the issue which is happening. This is another optical break condition, we have already discussed about it. And here what is happening is, as being you are going up, you have a flatter gradient, and when you have a flatter gradient you are feeling this type of a crest, kink at the in front of you. So, this is also another issue, and here you can see that there is a change in the direction in the horizontal profile, as well as a lot of vertical curves are there, and this is a view which is coming. So, in between you have lost the view. So, you do not know what is happening here, you do not know how the profile is going up and down. So, that is again not a good thing. Now, here if you look at this plan, a tangent continuous tangent line is there, but here we have provided a summit curve and a valley curve, which could have been very easily made a straight profile. So, a grade line could have been made, and that is the improvement which could have been done here. Now, here in this case also what you found is that the profile is going like up and down. So, this is up and this is down, but say if I just try to make it normal. So, what I can probably do is then I can bring it even here, and if I do this way, maybe I can just have a balanced cutting and filling, and this profile of the plan in the horizontal curve is quite smooth. So, then it will going to become a very good sort of a situation. So, these short humps which are there, they needs to be avoided by way of smoothing. Here again you have a tangent here, but first of all there has been a curve, but at that time the profile in the vertical frame was horizontal, and then it started going up, and in that you have the flitters, and these flitters can be again made perfect or balanced, and if that has been done, then these two things go together very easily and improves the thing. Now, here in this case what we can see is that there is a one curve here, there is another curve here. So, reverse curve condition is there, and there is a tangent in between, but this tangent is a short tangent, and because of this short tangent again the profile will have an optical break. So, here a few cases where maybe there looks good. So, you have a horizontal curve and a straight line gradient, in that case it looks like in this form. Here the curvature is there in the horizontal frame, as well as a valley curve is there. So, you get a sort of this thing, whereas this is again a curvature in the horizontal profile and a summit curve is there, then you get a view frame in this way. So, you have a perfect view, a smooth view, the lines are smooth. So, you are getting a smoother guidance in that sense. Again there are few cases where the two tangents are there. So, you are going straight. So, nothing change. At the same time the gradient if it is there, so there is not much gradient. So, you are going to get a simple smooth horizontal perfect straight line. But when you are having this tangent line and the curve is going up, then there is a smooth changeover in the upward direction, but if it is going down, then you get a curved situation here, which defines that now you are going to have something ahead that needs to be taken care of. Here again what you found is that the same profile is there, but because of this particular sag which is being provided here, and then a vertical curve is coming again in front of it, if that is being removed, then this becomes a smooth profile in terms of even the grade. So, horizontal curve is also there, as well as the gradient is also there, but they have been improved, and that is why it becomes quite good. But this has again the kinks, and these kinks are coming because you have the grade lines here. So, there is a combination of grade lines. So, this is defined as broken back grade lines, and we discussed about it when we talked about the vertical curves and said that these needs to be avoided. Here in this particular case what you have is a straight line, and then the curvature is there, but in the vertical profile it is going down. So, when it happens, then it creates a jumping situation. So, you feel that you are probably going this way and this way, that is on a situation here. Here what you found is that the curvature is at this point and the vertical curve is coming at this point. So, this is okay in this sense, but this first of all this curve is there, and then the this tangent is there, then another curve is also there. So, it is again a broken back condition in this form. So, if these things are being a bit improved at this location, means instead of going in this way, if something improvement has been done here, then you could have improved it further and becomes a good coordination there. Here we can see that there is a overlap as such here of this point and this point and this one, but what is happening is that after a long tangent you are going to get a a sort of a sharp angle curve, and that is also not desirable. So, in another case what we have is that there is a smooth curve as such, and here there is a vertical profile. Then if we look at these, they are more or less having apexes being overlapped with each other, and if that is the situation happening, then it is a satisfactory or good condition which is going to be there. The similar is the case here. So, here also like for a summit curve as well as a horizontal curve, they are getting overlapped, and in this one what it tries to say is that if instead of having this type of a curvature, if it has been smoothened, and if there is a possibility of doing that, then that is also going to become a better design rather than the other one, because in that case you have some problems of the angles. Here you can see that there are multiple of the horizontal curves as well as there are multiple changes in the vertical profile. So, when these type of things are happening and if they are coinciding with each other, then that is fine, then that means it is going to give you a good 3D view also. So, you have the guidance is being satisfied as we have discussed. Here in this case, as I said, that you have two changes here in the horizontal profile, there are three changes here in the vertical profile, but the first one and the last one, they are coinciding. The central one in the vertical profile is not having any curvature in the horizontal profile, rather there is a tangent, and this tangent also is going to give you a complete view frame, and that is why this is also going to be one of the good designs. But in this case what you found is that there is a shift of the apexes of the vertical and the horizontal profiles, and that shift we have discussed that it should not be more than 1/4, and that is what has to be looked at here in this case, and these all exhibits they have been taken from our guidelines also. Okay, similarly, here what you found is the things are, this one is in this point, then the tangents are there, and then there is a sharp curve. So, this needs a rectification again, and we have to take care of that, how this can be again carried out. Now, there are few cases which we can see, say in terms of this is a case from DPR, and from DPR what we found is that there are multiple of curves. So, this is a plan, this is elevation. So, in the elevation we found that there is curvatures here and there is a sag here. So, some fluttering is there and a dip is there. At the same time there is a horizontal profile, and if this location we look at, so it is coming at this point. So, and then if we are talking about the other one, so it is having a shift. So, that means now this one is not going to give you a good guidance, and there is a scope of improvement in it, subjective the sides of this particular alignments allow you to do that. Here in this case what you can see is this unnecessary shift in the curvature, this is a curvature here, and then you have a curvature, you go this way, then you go this way, and then you go this way. Probably this could have been made straight in this form and would have been better. So, that thing had not been taken care of while designing this and is unnecessarily creating a problem to the drivers. So, that needs to be taken. And then when you are going from this to another one, so here at this point there is a sort of a curvature at this. So, this could have also been omitted by way of a straight grade and a vertical curve, and that is where the things would have become better. Here again what we can see is this type of a kink which could have been very easily omitted, and then we are going up, then you have a straight profile and then a curvature here, but at the same time the gradient is also there. So, now if though it looks good in this one, the reason may be that there may be a shift of only say less than 1/4 of a phase in terms of the apex of the two profiles, but this is not required, that should have been changed. Here again what we found is that there is a curvature, and this curvature is coming with a gradient because you have something like a flyover here, and then there is a curvature again here. So, this is a vertical profile coming in. So, horizontal curve is coming at this point and this point, and vertical profile is coming at another point, and that is also again create a problem. The another issue is this extra lane, why this right turning lane has been provided, it has been closed and no measures has been taken if by any fault, if any driver comes in this particular lane, could have been hit at this location. So, with this we complete our discussion on this particular aspect of coordination of the horizontal alignments, and we are going to continue with a few other things which may be left or needs to be discussed or has to be seen in terms of good profiles, etc. Till then, thank you and goodbye.